Hi. So in this problem, we are going to look at a cubic equation, and there is a twist. The three roots of this equation are distinct, and they are the lengths of the sides of a right angle triangle. We have to find all the real p's so that this equation has three roots, which are the sides of a right angle triangle, right? So let's assume that the three roots of the equation are ABC like this. The roots are ABC, where this inequality is true. Why can we assume it? Obviously, some side will be bigger than the other, and all the sides have to be positive, so all the roots are also positive, right? By Vieta's relations, we have a plus b plus c, which are the roots of the equation, should be equal to 2p into p plus 1. We have ab plus bc plus ca is equal to p power 4 plus 4p cube minus 1. And also we have ABC is equal to 3p cube, right? And we know that ABC are the sides of a right angle triangle and C is the biggest side. So therefore C is the hypotenuse, and we have by Pythagoras theorem C square is equal to A square plus B square, right? Now our job is to use these equations to basically figure out the value of P that allows that to happen, right? So let's use the Pythagoras theorem, and we say that c square plus c square will be equal to a square plus b square plus c square. So therefore, 2c square is equal to a square plus b square plus c square. And we can write this as a plus b plus c whole square minus 2 times ab plus bc plus ca. And therefore, this becomes, using this relation 1 and relation 2, this becomes 4p square p plus 1 whole square minus 2 times 4p cube plus p power 4 minus 1. If you simplify this a little, this turns out to be equal to twice of p square plus 1 whole square is equal to 2c square. And that gives us c square is equal to p square plus 1 whole square. Therefore, c square is equal to p square, or c is equal to p square plus 1. How did we come to this conclusion? We got it by using this relation. 2c square is this, and we used equation 1. This is equation 1, this is equation 2. We used 1 and 2 to simplify this, right? We got c is equal to p square plus 1. Once you get this, we can use Vieta's relations again. And we say that we have a plus b plus c is equal to 2p into p plus 1. So we can say a plus b is 2p into p plus 1 minus c, and c is p square plus 1. So 2p into p plus 1 minus p square minus 1. So this becomes p square plus 2p minus 1. And similarly, ab is equal to p power 4 plus 4p cube minus 1 minus c times a plus b. And again, we use the relations again. We get p power 4 plus 4p cube minus 1 minus p square plus 1 multiplied by p square plus 2p minus 1. This is for c, and this is for a plus b, right? From the previous condition here, right? So once we do this, we can easily simplify this a little bit and realize that this becomes just 2p into p square minus 1, right? So AB is equal to 2p into p square minus 1, and a plus b is equal to 2p plus p square minus 1. So a and b are roots of this equation, u square minus u into p square plus 2p minus 1 plus 2p into p square minus 1. So what am I using here? I'm saying that if I know the sum of two things and I know the product of those things, I can construct an equation with those two things a and b as the roots, right? A plus b is the sum, so I've written this here because of Vieta's relation. Minus b by a is the sum of the roots, and similarly c by a is this. We have taken a as 1 here, the first coefficient. So we can easily solve this, and we can see that u can be 2p or p square minus 1, right? q is equal to 2p or p square minus 1, which are basically the two roots. So basically what we have is there are three roots A, B, C, where two roots can be 2p, p square minus 1, and the third root is p square plus 1. So we say we have already found C as p square plus 1, and A and B can be 2p and p square minus 1, right? So if you use the third equation now, which was ABC is equal to 3PQ, and we put these relations in that, we will be able to get this equation and get the values of P. So P square plus 1. So that is equal to 3PQ. And now we can easily solve this. P cannot be 0 because that will make the side here 0. So if P cannot be 0, we can cancel the P here. This becomes 3P squared. And if you simplify it a little bit, you get 2 times p power 4 minus 1 is equal to 3p squared, right? 3p squared. So you have 2p power 4 minus 3p squared minus 2 is equal to 0, right? This equation is a quadratic in p square, and when you solve it, you will realize that p square is equal to 2 is a root, right? P square is equal to 2 is a root, you can check, because if p power 4 will be 4, so 2 into 4, 8 minus 6 minus 2, right? P square is equal to 2 is a root, so p is equal to root 2 because p cannot be negative because one of the sides was 2p, right? So if p is root 2 is a viable answer for us, the sides become a, b, c are the sides, and the sides are basically 2 root 2, 1, 2 root 2, and 3, right? So we have found the three roots of the original equation. We have also found the value of p, which is root 2. And how did we do it? We used the conditions from data, the three conditions on the roots, and also the fourth condition, which is c square is equal to a square plus b square plus c square, right? So initially what we got was the value of c in terms of p. If you recall, if you go back, scroll back to the video, you got c is equal to p square plus 1. And then we used that c value in the other two Vieta's relations like this here. We said a plus b is this minus c, and we put c as b square plus 1. And we said ab plus bc plus ca is this. So we took all the c and the a plus b here, and we just simplified like this. Learn this technique because JEE Advanced has asked questions where you have to manipulate the Vieta's relations in different ways in order to get your results. So this is a question which typically can come in JEE Advanced, and you should be aware of how to manipulate these variables in an interesting way. That's it for this video. I will try and make more problem solving videos in the next few days. Please stay tuned, like and subscribe the channel, and share your doubts if any. If you have any doubts, maths or physics, please share them in the Google form link, and I will try and solve them as fast as possible. Right? See you in the next video.